We tend to use seats, please. Okay, the coffee break was a little bit longer than planned. I'm sure it was worth it. According to the schedule, I have the pleasure of inviting Mr. Matteo Natali from Wärtsilä Marine Applications Engineer, and he's going to talk about the use of cargo as fuel on LPG carriers, different machinery concepts. Okay, so the floor is all yours.
Yes, thank you very much. I'm going to say something about LPG burning capabilities as fuel on LPG carriers. You all know the market, you've seen it in the presentations before. The production of oil and gas refinery byproducts has steadily increased in the last few years, and with that also the availability of LPG. In 2015, 80 million tons of LPG have been traded globally, but what is more important to highlight is that most of these tons have been traded from and to ECA areas or possible future ECA areas. In order to trade these volumes, basically now we have two different possibilities, both with diesel engines. So if we want to run on HFO, we need an SCR and a scrubber, while if we want to run on MGO in the ECA areas, of course, we just need the SCR, we don't need any scrubber. And when it comes to the cargo containment system, of course, we have a reliquefaction plant always on to reliquefy the boil off. And this is fine. Of course, everyone was happy with this system and is happy with this system because especially now the oil price is really low. So it is very convenient to burn diesel. But like, what about tomorrow? We all think, believe and hope that the oil price will recover in the medium term. And if this happens, the possibility to burn LPG boil off as fuel on LPG carriers might become a very interesting alternative. In order to do that, we basically have developed this dual fuel technology. We burn gas with an Otto cycle, which means that the NOx emissions are very low, because NOx emissions are not related to the fuel you burn, but to the way you burn it. So with an Otto cycle, you have lower temperature in the combustion chamber, so you don't have high NOx emissions. So you don't need any kind of after treatment with this specific system. But of course, there's a challenge. LPG has a very low methane number, which makes it hard to burn as it is in a dual fuel Otto cycle engine. Because low Pentat number means basically knocking risks. In an Otto cycle engine, we control the fuel ignition with a pilot fuel. But if the methane number is very low, we risk self-ignition. But we have a way to avoid it, which is the gas reformer. Basically, the gas reformer, as you can see there, is a kind of magic box where you put bad quality, low methane number gas, and from which you get high quality, high methane number product gas. Basically, how it works, to make it very simple, the gas reacts with the steam, and then let's say the heavy hydrocarbons get split in CO2 and methane, to make it very simple. And as you can see there from the picture, there's an optimum operating range. If we have a feed gas that has a higher methane number than that optimum operating range, that is commercially better to derate the engine at burn and burn the LPG as it is. While if you go below that methane number, basically the CO2 content of the product gas would be really high, and that translates into a low heating value. On the other hand, actually the flow would be higher because there would be more steam. So it would be still possible to use the gas reformer, but we would need to do some engine tuning to let more gas in the combustion chamber. But yeah, let's do some number crunching now, and I would like to present you a case study we've worked on last year on a very large gas carrier. It's a 83,000 CBM ship that trades LPG from Houston to Le Havre, so from and to ICA zones. And what we've done is comparing a traditional diesel system towards 3 different alternatives that burn only LPG. As we can see in the traditional diesel system, of course, we have a 2-stroke engine with an FEP and 3 generators. And all engines are connected to an SCR to be IMO 33 compliant. And when in ECA zone, with this configuration, we burn MGO. And of course, our liquefaction plant is fit on board. The 2-stroke high-pressure gas system, which is basically the MEGI system, has a 2-stroke high-pressure engine connected to an high-pressure system, and then 3 dual-fuel auxiliary engines connected with a very small gas reformer. The main engine runs according to a diesel cycle, so it needs after treatment, and we have an EGR there. And then we have the 2 dual fuel options. The first one is a 2-stroke dual fuel engine, the XDF, which needs a 16-bar compressor system for the boil-off, and of course the gas reformer for both main engine and auxiliary engines. And on top of that, actually here we need an extra boiler to make the gas reformer work. We need a lot of steam generation, and the exhaust gas of the 2-stroke engine are not hot enough to make the gas reformer work. So we need an extra boiler. That will entail, as we will see, extra maintenance and extra fuel consumption. And then we have the last alternative. It is the 4-stroke dual fuel alternative. Here the auxiliary engines are smaller because during sailing we don't use them at all because we have a PTO and connected to the gearbox. And unlike the other versions, we have a CPP and not an FPP, which costs a bit more. And of course, the gas reformer for all the engines. The operating profile, basically the vessel, as I told you before, is sailing from Houston to Le Havre and back, and the average speed is 16 knots. In case of the dual fuel configuration, of course, the reliquefaction plant doesn't run. So we have the liquefaction plant installed on board because we said that, yeah, for commercial reason, we need to have it on board anyway, but it's not. It's basically never running. So actually the consumption, the energy consumption is a bit lower. Let's see some numbers here. This is the initial cost. Basically, the gas 2-stroke engines are a little bit more expensive than the traditional solution, and the 4-stroke, and then the 4-stroke solution. But if we consider the whole system, we see that the diesel alternative is still remarkably cheaper. And then on top of that, we install a liquefaction plant, as I told you before, in all configurations. Even if with a dual fuel engine, in theory, we would not need it. So from the ship owner perspective, we have considered the capex, let's say amortization. We've considered 15 years with a 3% interest rate, and we've considered all the maintenance costs and all the consumables except, of course, fuel. And we see that actually the diesel solution is still the cheapest one for the ship owner, but the gap with the dual fuel solution is not big at all. Of course, the 2-stroke high pressure system has an higher capex, and requires higher maintenance costs both for the high pressure gas handling system and for the liquefaction plant that is always running compared to the dual fuel solutions. If we move to the charter perspective and we consider the oil prices today, so a very low oil price, we still can see that today it is convenient to invest in a diesel system. But of course, when you buy a ship, you buy it for 25 years, not for a few months. So if we look at the oil prices tomorrow, we see that the gas configurations become the most beneficial for the charter business case. And as we see, we can have 20% OPEX, let's say fuel consumption reduction with a gas system, and 15%, actually only 15% if we have a two-stroke dual fuel system because of the boiler, because of the extra fuel we need to burn to make the gas reformer work. When it comes to references, the 4-stroke dual fuel system with a mechanical drive already has some sailing references, so to say. So we have managed to fine-tune this configuration, this product, quite a lot since we launched it. We have signed a series of ethane carriers for Evergas, and we have also the Coral Energy, an LNG carrier built for Anthony Vader. But of course we have, and this is just for gas carriers, of course. Then we have many more references with a 4-stroke DF mechanical drive in the merchant segment. On the other hand, for the gas reformer, we have only one reference, but we have prototypes running as we speak on LPG, right? We have 1 megawatt gas reformer prototype running on LPG now in Basa, and a lot of testing has been done on the gas reformer. So it is, I would say, it's a proven technology because we have tested it for really a long time, very successfully. But even if we don't have many references. And another thing that is important to mention is that with this system, with a dual fuel system, so by burning the natural boil-off gas, we don't have LPG under deck, which is actually good because it reduces the safety risks of the installation. So the boil-off goes to the gas reformers, which is placed on the main deck, and then from the gas reformer, basically methane or natural gas goes to the engines. So if we put all these factors together, which are basically emissions, references, and operational expenditures, both for the charterer and for the owner, as well as safety issues, we see that the 4-stroke dual fuel system combined with the gas reformer is an alternative that is at least worth considering for new build LPG carrier. And of course, if you would like to know more about this technology, or if you would like to have this kind of calculation made on your specific business case, you are free to contact us anytime.
Thank you very much. That was very interesting. Do we have any questions? Okay, so I have a question then. You mentioned about the issue of knocking because of the O2 cycle and because of the methane number, correct? There is also, we hear some concerns when engines burn gas on methane slip. Can you tell us what have been the latest developments from your company on that aspect?
Yes, actually that's a really good question. Methane slip used to be an issue when we first launched the dual fuel technology, but in the last few years, a lot of work has been done, both on the geometry of the combustion chamber and on the timing of the injection. So now the problem has been, let's say, drastically reduced, and it's not a problem anymore. Anyway, if we consider, even with the worst values that we had a few years back, the CO2 equivalent of a dual fuel engine emissions compared to a diesel emission, even adding the methane number, a dual fuel is still more, I would say, green solution.
Okay, thank you very much. Okay.